Welcome back, everyone. Ready to dive into something truly mind-blowing?
I'm ready. What are we looking at today?
Today, it's biomining in space.
Wow, hold on. Biomining, like with the microbes.
Yep, and we're talking about using them to get valuable resources from asteroids.
Now that's some serious sci-fi stuff.
Except it's not sci-fi anymore. It's a real field, and it's getting a lot of attention, and for good reason.
Okay, I'm hooked. Tell me more. What is biomining and how does it actually work?
Imagine like an army of tiny miners, bacteria and fungi, going to work on asteroids.
You're saying we're using microbes to mine in space?
Exactly. They're incredibly efficient at extracting valuable metals and minerals from rocks. It's like they've evolved to do this.
Okay, I can see the appeal of having like a microscopic workforce already out there in space. But how do they actually do it?
Well, one way is through bioleaching. These microbes actually produce acids, strong acids like sulfuric acid.
Wow, sulfuric acid. That's some powerful stuff.
Right. And they use it to dissolve the rock and release the metals that are trapped inside.
So it's like a natural process they use to break down rocks and get to the good stuff.
It is a natural process that we're now trying to harness for space exploration.
It makes you wonder, why not just send regular mining equipment up there? Seems like that would be more straightforward.
Well, think about it. Launching heavy machinery into space, all that equipment, the fuel it would take.
Yeah, you're talking about massive costs and logistical nightmares.
Exactly. Biomining is a way more efficient alternative. It requires far less energy, which means less to launch into orbit.
That's a big deal when every ounce matters.
Yeah.
Right, the lighter the payload, the better.
Right. Plus, these microbes are incredibly tough. They can survive in really extreme environments like, those found on asteroids.
So we're talking temperature swings, radiation, you name it.
Yep, those asteroids are tough places, but these microbes, they've evolved to thrive in those conditions.
Makes them perfect candidates for the job. But okay, so what about the treasures themselves? What are we hoping to find on these asteroids?
Oh, it's like they're cosmic vaults filled with all sorts of valuable resources. Think nickel, cobalt, iron.
The stuff we use for everything, from buildings to spacecraft?
Right. We could even potentially source building materials in space from those asteroids.
That's a game changer right there. Imagine building structures in space using materials mined right there in space.
Exactly. And don't forget the rare earth elements.
Ah, yes. Those are crucial for all our advanced technology, everything from electronics to renewable energy systems.
Right. Asteroids are like a cosmic supply chain waiting to happen.
It's incredible, but
Yeah.
let's be real for a second. How do we even know these microbes can handle the harshness of space? I mean, we're talking extreme temperatures, radiation, zero gravity. It's a lot.
It is a lot, and that's a question scientists are exploring. But there's hope. There are certain bacteria called extremophiles.
Extremophiles. The name says it all.
Exactly. They've evolved to withstand some of the most intense conditions imaginable, even in space.
So we're talking microbes that laugh in the face of radiation and extreme temperatures.
Pretty much. And here's something even crazier. Studies have shown that some bacteria actually grow faster in low gravity.
No way. So space is like a growth accelerator for certain microbes.
It seems that way. It's like the lack of gravity gives them a boost.
Wow. So we might not just find microbes that can survive in space. We might find microbes that actually thrive there.
That's the exciting part. And now scientists are looking at how to engineer microbes specifically for space mining. Think synthetic biology, bioinformatics.
So we're talking designer microbes, custom made for space.
Exactly. Microbes that are super efficient at extracting specific resources, designed to thrive in those asteroid conditions.
It's like a whole new era of bioengineering, tailored for the cosmos.
And get this, biomining is also promising for cleaning up toxic waste in space.
Ah, bioremediation. That's crucial if we're going to have a long-term presence in space, for those longer missions and habitats we've been dreaming of.
Absolutely, got to keep things clean. So how would we actually deploy these microbes on an asteroid? Just like sprinkle them on the surface?
Well, it's a bit more sophisticated than that. There's direct bioleaching, where you release the microbes right onto the asteroid's surface.
Simple and straightforward, makes sense.
Simpler, sure. But keeping those microbes alive and doing their job out in the open like that, it's a challenge.
Right, the space environment is pretty unforgiving.
Exactly. There's also indirect bioleaching, which involves growing the microbes in a more controlled environment, like a bioreactor on the asteroid.
So like a mini lab right there on the asteroid, keeping those microbes safe and sound.
Precisely. The microbes produce the leaching agents inside the bioreactor, and then those agents are applied to the asteroid rock.
So more control over the process and better protection for the microbes, it's a trade-off.
Right. Each method has its advantages and disadvantages,
Mm.
and scientists are working on figuring out the best approach for different situations.
I can only imagine trying to balance efficiency with keeping those microbes alive in such a hostile environment.
Oh, it's a constant challenge. And then there's microgravity. It can affect how microbes behave, how they interact with surfaces.
So even if they grow faster in low gravity, that doesn't automatically make them better miners.
Exactly. We need to figure out which microbes work best and understand how they function in microgravity. Plus, there's always the radiation, the temperature swings, the vacuum conditions.
Yeah, it's a lot to contend with. It's amazing to think that scientists are tackling these challenges head on. Are there any projects or experiments that are giving us hope for the future of biomining?
Oh, absolutely. Despite those challenges, there's been some incredible progress, like the BioRock experiment on the International Space Station.
Bio-rock. What was that all about?
It actually proved that microbes could extract rare earth elements from rock, even in microgravity. Basalt rock, to be precise.
Wow, so biomining really can work in space.
It can. And this experiment gave us a ton of valuable data about how microbes behave in microgravity.
A stepping stone for future missions.
Exactly. And there's the BioAsteroid project. Scientists are simulating asteroid conditions right here on Earth.
Sort of like a dress rehearsal for a real asteroid mission?
Exactly. They're testing how different microbes interact with those simulated asteroid materials. It helps them identify which microbes work best and how to optimize the whole biomining process.
It's fascinating to think that all this research is happening right now, laying the groundwork for a future where biomining could become a key part of space exploration.
It's an exciting time to be following this field, that's for sure.
Welcome back to our deep dive. So we've been talking about the amazing potential of biomining in space. But before we get too caught up in the excitement of all those space treasures, we should probably take a step back.
You're right. It's important to think about the big picture, the implications of what we're talking about. I mean, we're talking about changing how we interact with space, not just visiting, but actually using its resources.
Exactly. And that brings up some pretty big questions, like who owns those resources in space? Are asteroids fair game? Or is there a need for some kind of system for access, something fair and responsible?
That's something the international community is grappling with right now. You've got the Outer Space Treaty from way back in 1967.
Yes, the treaty that says no one country can claim ownership of celestial bodies.
Right, but it doesn't really address commercial activity, like mining.
So there's a bit of a gray area when it comes to owning what we mine from asteroids.
There is, and there are a lot of different perspectives on this, and it's getting pretty heated. Some people believe companies and nations should be able to mine freely, drive innovation and boost the economy.
Makes sense. After all, that's kind of how things have worked here on Earth.
Right, but others argue that space resources should be shared, managed for the benefit of everyone on Earth, to prevent exploitation and ensure everyone gets a piece of the pie.
Yeah, I can see that point too. It's tricky, balancing progress and profit with ethical considerations.
It is. It's not an easy question to answer. And then there's the environmental angle. We're talking about introducing Earth microbes into a whole new environment.
Right, asteroids are like, well, we think of them as lifeless rocks, but do we really know for sure? What if we mess up some delicate alien ecosystem that we don't even know about?
That's a concern that scientists are taking very seriously. Planetary protection is a top priority for space agencies worldwide.
So it's about minimizing the risk of contaminating other celestial bodies, even if it seems unlikely.
Absolutely. We have to proceed with caution. The last thing we want is to discover alien life only to realize we've already contaminated it with our own microbes.
That would be a disaster. So what kind of precautions are being taken?
Well, for one, they're developing containment strategies for biolanding operations, to prevent accidental release.
So like making sure those microbes stay put and don't go wandering off to colonize the solar system.
Exactly. Those closed-loop bioreactors we talked about earlier, they help.
Right, I remember. So they're not just about efficiency, they're also like, biohazard containment units.
You got it. And there are all sorts of other protocols in place, like sterilizing equipment before launch and choosing landing sites carefully. It's a multi-layered approach.
Like a cosmic version of leave no trace. But all this talk of careful protocols and planetary protection, it makes you wonder, couldn't this technology be misused? What about weaponizing biomining?
That's a valid question, and it underscores the need for international cooperation. We need clear guidelines, treaties, you name it. Like any powerful technology, there's always the potential for misuse.
So instead of mining resources for, well, peaceful purposes, someone could use it to mine stuff for weapons or military applications.
That's the concern, and it's something we need to be mindful of. That's why having clear international regulations and treaties to prevent the militarization of space is so important.
It's a reminder that even in space, we're not escaping the complexities of ethics and responsibility. It's important to have these conversations now while the technology is still developing.
Couldn't agree more. We need to establish guidelines for sustainable and responsible practices in space.
Okay, so we've covered the science, we've talked about the ethics, and I think it's time to get down to business. What about the economics of biomining? Is there actually money to be made in space, or is this all just, pie in the sky speculation? Welcome back. We've talked about the science behind biomining in space, and we've even touched on some of the ethical dilemmas, but now let's talk money.
Now we're talking. Everyone wants to know, can you actually make a profit mining asteroids?
It's a good question. I mean, I get it. Asteroids are basically giant rocks floating in space, but you're telling me they're worth like trillions.
Oh, we're talking way more than trillions. Some estimates put the value of resources in the asteroid belt at quadrillions of dollars. Metals, minerals, the works.
Quadrillions. That's like, I can't even comprehend a number that big. But, okay, let's be realistic here. Getting to those asteroids, setting up these biomining operations, bringing all that stuff back to Earth, that's got to be expensive.
You're not wrong. The initial investment is significant, no doubt about that. We're talking cutting-edge spacecraft, sophisticated bioreactors, all the infrastructure to support operations in deep space. It's a huge undertaking.
So this isn't some like get-rich-quick scheme. This is the big leagues.
It is, but just like any major mining operation here on Earth, you've got big upfront costs. The key is to look at the long game. Think about the potential. Unlocking vast, untapped resources that could benefit humanity for centuries.
So it's a calculated risk.
It is,
Hmm.
but the payoff could be huge. If we can successfully tap into those asteroid resources, those initial costs will pale in comparison to the potential profits.
It's like a, I don't know, a cosmic gold rush, but with microbes instead of pickaxes.
I like that. But unlike those old gold rushes, this one's going to be driven by big... It is. And we're already seeing the early signs. Companies investing in asteroid mining technologies, new spacecraft designs, even in-space manufacturing platforms.
Wow, it's like something out of a science fiction novel. But what about the impact here on Earth? If we suddenly have all these new resources coming in from space, won't that mess up the markets?
That's a legitimate concern. A flood of new resources from asteroids could definitely shake things up. Supply and demand, prices could fluctuate, some industries could be disrupted.
Right, like if we start mining platinum on asteroids, what happens to the platinum industry here on Earth?
Exactly. It's something we need to think about carefully. But this disruption could also bring new opportunities. Imagine an abundance of rare earth elements. That could be a game changer for renewable energy, electronics, all kinds of industries.
So it's not just about the resources themselves, it's about how biomining could spark innovation and drive technological advancements in all sorts of fields, right?
Absolutely. Think about it. Developing these biomining technologies is going to push the boundaries of synthetic biology, bioengineering, robotics. We're talking new industries, new jobs right here on Earth.
Wow, the ripple effects could be huge. This is getting me excited about the future.
Me too. It's about pushing the limits of what's possible,
Yeah.
expanding our horizons, and ultimately using those space resources to benefit everyone here on Earth.
This has been an amazing deep dive. We've gone from the microscopic world of microbes to, well, the vast economic potential of space. It's incredible to think that we're even having this conversation.
I know. It's a real testament to human ingenuity and our drive to explore, to push the boundaries.
We've talked about the science, the ethics, the economics, the challenges, and the opportunities. And I think the big takeaway is that biomining in space, it's more than just extracting resources. It's about expanding our understanding of life, of our technological potential. It's about venturing into the unknown with a sense of wonder and responsibility. And who knows what incredible discoveries are waiting for us out there as we continue to explore the cosmos.